Okay. Well, good morning, everyone, and good afternoon and good evening for some of you. Welcome to our Day of Learning session, which is on work we've been doing with Red Hat Research and social innovation. So it's a real privilege kind of for me to share this really interesting and exciting project with you. And before we start, I'm going to cover a little bit of background because we will mention something called fireware throughout these presentations. And you might be wondering, what is or who is a fireware? Well, fireware is a not-for-profit foundation based in Berlin, in Germany. And originally they were funded by the EU, by the European Union, and now they're funded by a membership program. And Red Hat is a member of the Fireware Foundation. We're a platinum member, along with some names that you'll probably recognize, like NEC, Atos, and Telefonica, who were all founding members of the Fireware Foundation. And their most recent member is AWS, Amazon Web Services. So Fireware developed a catalog for data models and a piece of software called a context broker. And the context broker allows you to consume data from all sorts of different devices, from things like sensors, video cameras, third-party databases, satellite imagery, a whole range of different data in a whole range of different formats. And what Fireware does, what the software does, is kind of normalize that data into a coherent whole. And this allows you to create smart solutions for everything from villages and cities through to agri-food, manufacturing, utilities, healthcare, sustainability, just to name a few. The portfolio or the domains that Fireware are working in are, they're expanding on a kind of almost on a weekly basis. So in a moment, I am going to introduce you to the dream team. But just before we do that, what I'd like to do is kind of give you a little bit of a kind of an overview of what we're going to go through in the next hour. As you can see, we've been very busy, so there's a lot to get through. And feel free to ask questions as we go. I'll do my best to keep one eye on the Q&A, and we'll do our best to respond to those questions in the flow of the presentation where we can. And if not, we've got time at the end for Q&A. Also, if for whatever reason we don't get to your question or we don't get time for Q&A, make a note of my email address. It's jimc@redhat.com. Whiz me an email with the question in, and what we'll do is either respond to you directly, or if we get a significant number of questions, we'll compile them into a document and share that document with you, so you get kind of everything in one place, and you get to see answers to questions that other people might have asked as well. Okay, so what I'd like to do now is invite you to the dream team. So we, it's been amazing to work with these folks, and what I'm going to do is I'm going to be quiet and let them introduce themselves. So I'll start with Yingqing Chen from Boston University.
Hello, everyone. My name is Yingqing Chen, and I'm a second-year PhD student of Systems Engineering Department in Boston University. And my advisor is Professor Christos Cassandros, who also actively involved in guiding me and through this project. My research interest is optimization and intelligent transportation system, which matches perfectly with this topic, and is a great honor for me to join this project and attend this event. Thank you.
Thanks,
Hi all. My name is John Malmgren. I'm from Smart Villages in Sweden. It's a small village here called Veberöd, and I have a background in tech development and tech design. And now I have a passion for village development. Thank you.
Hi, I'm Christopher Tate, and I'm a Red Hat principal consultant. I'm active in the Red Hat research team right now, working with Boston University and with smart device technology. And I'm also a Red Hat principal consultant in financial services and help develop event-driven automation there. So back to Jim.
Thanks, folks. Thanks, team. Now, almost 2 years ago now, was it nearly 3 years ago now? Yeah, almost 2 years ago now. Some Swedish guy popped up on LinkedIn and asked me what I thought at the time was a really interesting question. And so what I did was, as I always do, I went around different parts of Red Hat to see if I could get some support from this. And I can't remember who it was now, but somebody directed me to Hugh Brock, who leads Red Hat research. And he suggested submitting an application for some funding through our relationship with Boston University. I'll say Boston University. I might also say BU at sometimes if you wonder what I mean by BU. So we've had this relationship with BU since 2014, since the Massachusetts Open Cloud. And with some help, actually with a lot of help from Yingqing's principal, Christos Kassandros, we submitted what turned out to be a successful bid, a successful application for some funding, and that's what's been able to kind of sustain the project to where we are now. So what I'd like to do is kind of hand you over to Jan to give you a bit of background to what he's been doing and why he chose Red Hat as a partner that he'd like to work with. So over to you, Jan.
Thank you. I'll try sharing here. Can you let down your presentation so I can? Cool, thanks. Hope you see all this red screen.
Yes, we can.
Great. Well, first of all, I got interested in Red Hat because of a post that you, Jim, posted. And I got the idea of what we're doing, if that can be done in open source and spread more easily. And when we start talking, I get really passionate how you think. And I certainly got really passionate about social innovation. And we have this long talk, Jim, you remember? Back and forth, and I really got to like how you think. And that started up a cooperation with us, Smart Villages. And I will try to fast explain what we are trying to do. Smarta Byar, or Smart Villages, we try to do a global research village powered by FireWare and Red Hat. And it's a very small village, about 5,000 people. And it actually started in 2008, like a local communication platform with my son, who was 11 at the time. And in 2018, we started Smart Villages, an IoT platform to have a balance to the smart cities. I thought this was really cool to meet up with technology in rural areas and still use the high tech like Red Hat and FireWare and stuff like that. But it started with a move. It started with water bins for cows, where we deployed sensors for measurement of levels in water bins for cows. And we got a real hit of measuring this. It got really, we got information when the herds were coming and when the solar power pump was stopping, because it was stopping a lot and causing a lot of problems. So it was a proof of concept that we done first. After that, we tried to deliver medicine with drones within the village. And we did that because we wanted to find out what the village was thinking about drones and technology. And we asked the village, and those who voted said that 91% really liked what we do. So that was the kind of the seed of starting up as a test village for what is sustainable. We continued with smart trees. We actually connected trees in the village, and we have a company who do a lot of trees every week in the village. So we connected those, and it measurement of moisture in the roots of the tree. So we actually connected trees in the village, and they were telling us when the water was down and we needed to go water it, and we saved time, money, and water, of course, as well. We tried to continue with this proof of concepts, and the next one was tracking bikes. And we worked with a few companies that actually built a sensor with IoT that woke up and signaled where the bike was. So this is my bike, actually. We have 5 bikes deployed in the village. And when I was in another village, drinking beer, actually, I got a notification on my phone that my bike was moving. So I called up the village, and I also have online the police alert. We actually could track the bike. And when we were finished, I just go to the address and find my bike. Another proof of concept. We also work a lot with youngsters. This is an example how youngsters looked into water in the village. It's actually the stream, the small stream that is coming in to the village and leaving the village. And what we were trying to do is find out, do we contaminate this water? What is coming in and what is leaving? And with real laboratories, we found out that we were adding magnesium and zinc and other pollution, but not much. So we are like let's say a nice minus village. And we try that to get that information for the municipality. To do that, we actually can leave cleaner water. We continued with water, and this is 2 startups. The first is actually a stone in the middle. It's not a stone, it's just camouflaged as a stone, but it has 6 different kind of sensor for water quality. And that was live. And the next picture beneath is wireless LoRa water valves that we can actually connect to anywhere where we have water. And then to the right, we have a water company, a big water company here, that uses 1,000 sensors in the village to measure the flow and temperature and pressure of the water that we drink. And the result was also a heat map of the use of the water in the village. We also connected doctors. This is the really beginning of pandemics, and we connected doctors via AR, augmented reality. So we connected them in virtual reality and augmented reality to see that doctors actually can be in place to help out, even in a small rural area like a village. We continue with different kind of examples. This is smart lampposts. We put out 5 lampposts that detect when cars come in, and they dim up from 20% and up to 100, and also can detect if there are pedestrians crossing. So this is a project where we save money and in energy, of course, but also increasing traffic security. We continue. We have a lot of examples, but we also did a big 3D model. We saw a need for visualization of the village and how this organism of a village work. We made a 5 square kilometer big 3D model of the village. So this is it, and we can actually zoom in and we add sensors, and we use fireware for this and a platform called Ugo. Here we want to test different kind of sensors. In the foreground, we see a gate for a preschool where we indicate when a parent forgot to close the gate, and then we and the teachers got a notification that it has been left open. We love to ask the village about stuff. And one question was, where do people drive the fastest? And this is the map we got out in 2 days. We got 11 places where people was complaining where traffic was too high. We used that information and worked together with a private person to put up a radar. So we actually started to measurement of traffic flow, speed, and everything you can measure in this. And we had data now for 1.5 years back on this. We continue with road safety. This is a company called Universes. It's using an AI Edge mobile phone, which means that you have the AI in the phone when it looks. So I just put the phone in the front of on the window of my car and go around. So the little small yellow squares are actually cracks in the road. It automatically detects everything on the road, even traffic signs, and out comes the 2D map of levels of damages, where we get this to the municipality and they can repair the roads. And at this step, we also got a new traffic project with Red Hat and Boston University. And I think I will get back to work to you, Jim.
Yeah, thank you, Jan. Thanks for the background and the context there. That was really helpful. What I'm going to do now is hand you over to Christopher to really see how, what work we've done with the investment that we've received in collaboration with Boston University so far. So over to you, Christopher.
Yes, thank you. So you see my screen now? Let's see.
Yes, we do. Yeah.
Oops. There we go. Now, I got connected with this project through the Social Innovation Program. I help as the architect in the Social Innovation Program to bring on new projects and develop hackathons and things within Red Hat engineering and consulting. And so I was brought on board to help with the project, to help develop the open APIs and a dashboard to interact with external services to gather live data, like the sensors that Jan was showing out in the village, the live data out there, as well as interact with open source applications to simulate traffic in the city of Veberod and gain new insights into building smart traffic lights. And Boston University students like Yingqing are helping to drive that research and development of smart city indicators, including smart traffic lights in the village. And why would we do a smart traffic light? It can help improve traffic, it can help improve safety, it can help improve pollution and overall happiness in the village. So it's really cool to work together. And we developed these open APIs and a dashboard together, and you can see it live in production at smartvillage.computate.org. And we're going to dive into more details there. But you can see in the bottom here our IoT node data that we've imported and a map of these IoT nodes in our dashboard application. So running social innovation projects in the cloud deserves the best in security, high availability, scalability, updates, and storage, which Red Hat OpenShift provides. And there's an environment called Operate First that the Red Hat research team helps manage, where projects can be onboarded into an OpenShift environment and deploy their applications in the cloud. And we'll take a look at that too. Red Hat OpenShift provides these things. And we want to look at a traffic simulation. So I'm going to stop sharing and switch to our OpenShift environment here. You can see we're using some of our quota here to run the dashboard. And we're going to add more applications like the Fireware Context Broker that Jim talked about earlier. So you can see, let's go to our route here for our Smart Village application. And you can see it running here. Now we have articles in the site of what we're doing, so you can get the latest updates here and how we got started and about our open APIs, for example, and our Kubernetes components here. We explain how we do our routes and deployments and image streams. We have a container on Quay.io. And so we're always updating the builds and getting them deployed to OpenShift. Our project is open source, and you can check it out here. We have documentation for how to deploy the project locally on your computer and Ansible scripts to get that running, and also how to develop it in Code Ready Studio, and how to get it deployed to OpenShift. Now, we want to see a simulation, right? So let me explain traffic simulations. This site is backed by Red Hat single sign-on for role-based access control to the data, which is important. And we define simulations that use open source tools like the Sumo traffic simulator software. It's open source and can put vehicles and people on the roads in a simulation. And that's what we're doing here. So let me show you our many map results. And in the beginning, this, I'm going to pivot on location. This only included vehicles in the beginning, but since then, we've been able to add many more types of data. And let me make it show 500 objects at a time. And we're going to filter on the simulation here, Webrod intersection. And then we're going to get some stats here for time in seconds so that we can run a simulation. Now, every 1 second in actual time, is going to be condensed to a half a second. We can animate this simulation on the map. And you'll see that vehicles in yellow are coming through the intersection from the bottom to the top, but the people in purple are also able to pass. The green traffic light here is letting traffic go in one direction, while the other direction, people and vehicles are getting queued up. Now the light just changed from green to red. Green to red, and now traffic is flowing in the other direction, including people and vehicles. And now it's switched again. So now they're going in the other direction. So this is a really fun simulation that puts people and vehicles and traffic lights on a map at the same time. And these are the open APIs. I was going to show you one more thing. The open API spec is available here. There's some documentation about it. But anybody who wants to see these open APIs can check it out here. So that is a little intro. We'll get back into this later on, but I want to pass it back to Yingqing to talk about the research that's been going on at Boston University.
Hi, can you see my screen now?
Yes, we can.
Okay, cool. As Chris just mentioned, we want to gather data and simulate traffic through the platform. And the first use case is smart traffic light control in Webrod. And when we say smart, we mainly want to dynamically adjusting the traffic light cycle in an intersection in order to improve the overall traffic performance. And firstly, this is the map of Webrod, and the intersection inside the red circle is our target intersection, located at the center of the village. And when presenting it in simulation, it would look like this. And currently, the pedestrian manually requests a green cycle to cross. So our goal is to make the traffic light more smart. To achieve that, we want to use some IoT devices to collect data, and we want to learn some traffic patterns and make the traffic light automatically adjust themselves to minimize the vehicle and pedestrian waiting time. To theoretically analyze the traffic in that intersection, we further abstract it into this format. As you can see, we consider a single intersection and only straight directions for now. But one of the major differences is that we consider not only vehicle flows, but also pedestrian flows, which has been largely ignored, even though it's clear that it plays an important role. We also want to define a set of light switching policy considering both vehicle and pedestrian state to make the light switching more reasonable. And the policy is influenced by 10 controllable parameters. So one scenario we often encounter is that we wait in front of the red light, but on the vertical competing road, there's no vehicle crossing. So one example of this policy is that when such scenario happens, we want the light to switch to green immediately and automatically. In that case, unnecessary waiting time would be prevented. So with those policies, the waiting time should be decreased and the light switching should be reasonable in practice. And since the policy is influenced by those controllable parameters, we want to adjust those parameters automatically by predicting the effect of changing green light cycle based on some actual data. So here is an example of simulation considering both vehicle and pedestrian in single intersection in Sumo. And Chris has transplanted into the platform as you see before, and for a better view. So then it comes to how it might work in practice. This is our target intersection. We want to equip it with a smart traffic light and traffic camera to gather some data. And we also have some controller that they can transmit data with each other. And in this procedure, traffic light and traffic camera will send data to the controller. And this is not hard at all because the data we need are basically some events such as the time of light switching or the time that the queue becomes empty. And when getting those data, the controller would calculate and adjust parameters, then optimize the waiting time. And the controller will send back the control to the smart traffic light and to complete this procedure. And all these procedures are driven by some real data from WebRoad IoT devices. And here is a sample data detected by IoT devices in WebRoad right now. And next, I would briefly present some simulation results showing the effectiveness of the method. First result is under the stable traffic demand. We want to know how the average waiting time would change with time when making automatic control. So the x-axis is time and y-axis is the average waiting time. Left plot is for both vehicle and pedestrian, and right plot is for pedestrian only. So we can see that the traffic light learns the best parameter setting in a little over 1 hour. That's pretty fast. And the average waiting time is reduced by about half. It drops from more than 11 seconds to more than 6 seconds. And also, the average waiting time for pedestrian only is reduced about 30%. So this result shows that it works well in stable situation. Then in changing traffic cases, we can find from the plot that it can automatically adjust themselves to adapt to the changing traffic condition. So the shaded area is the demand increasing area, and we can say the waiting time drops in all 3 demand ranges. Finally, this set of simulation is similar, but using some real data of target intersection in WebRoad. We want to know how would the average waiting time change with potential traffic demand increase. We first simulate the baseline scenario, which is the current situation in WebRoad, denoted with the blue curve, and we mainly compare it with the green curve, which is our optimized performance. So we can say that the green curve is always slower than the blue curve and about 34% less waiting when traffic demand doubled. So it shows that the smart traffic light works better than the current baseline policy, and it works even better when traffic demand expands. So we can see about 34 less waiting when the demand doubled. So this is how we control and simulate in this project. And I give it back to Jim now.
Thanks, Yingqing. That was really cool. Thank you. What I'd like to do now is, you've seen we've got real data from the village and we've got simulated data that Yingqing has been working on. Chris, can I hand it over to you to walk through how you've kind of brought those two things together, and then go from there and talk about what your future plans are for the data simulation and the real world data, please. You're on mute, Chris.
Okay, thank you. We are reporting on many types of map results: vehicle steps, person steps, traffic light steps, IoT nodes, and someone just brought up bicycles. So how do we include all of these things, like live data from IoT nodes that can be merged with simulated traffic data, and traffic data includes vehicle and people and traffic lights over time? Let's get into those kind of details here. So let me jump back to our simulation here, which is actually still going on. It's very fun. And let me show you that we have different ways to analyze this data over time. So we can change the range of this to be back in November. Okay, so you can see here when these vehicles and people and traffic lights were imported. And we track vehicles and people and traffic lights over time. And that's why I call it a step. It's a step in time. And so we have, looks like 15,000 vehicle steps and 12,000 person steps and 1,000 traffic light steps here. So each of these have a separate API and corresponding dashboard. We have vehicle steps, we have person steps and traffic light steps, and our IoT nodes. So we build open APIs around all of them, but they all inherit an inherited class of map results. That way we can bring them all together into one graph or into one map and simulate that data over time. Now, I'm a software developer, so if you want to see how this works, I'll give you an example here. We have a traffic simulation. Let's go into the project and create something new. Like, we have person step here. Let's create a new class. Other Java class. We'll call this bike step, and we'll put it into a package called, maybe I should say, bicycle step and bicycle step. Now we have a bicycle step class. I'm going to give you a very brief introduction to the code generation tools that I've been building over 16 years that help generate these APIs and dashboards. And it's referenced here, the Java class reference. There's a whole bunch of things that you can do to create these APIs automatically for you. And as an example, I'll just go to this person step class and copy some data here and then explain it rapidly. So it contains an API, it has a page, its super page is map result, its indexed in the search engine. Its order is number 12. In models, we'll call this bicycle step. We'll give it an API of bicycle step. And it has a search API, a get API, a patch API, a post API, an import API. And it's going to have a page of bicycle step. Bicycle step is, this is the dashboard page. And you have to be it recommends being a site admin to manage this. Here's some language context, bicycle step. Now I'm going to save, oh, this isn't valid, so let's change this to be bicycle step. Extends a class that doesn't exist yet called bicycle step gen. Oh, we're going to see some magic happen behind the scenes. There's a systemd service behind the scenes that's running and watching this code, and it actually just generated a whole bunch of code for us. Let's save it one more time. Oh, we need to import an object here, and then you'll see that it's generated some getters and setters and initialization code for this bicycle class, all kinds of useful stuff. And also it's generated the entire Vertex reactive asynchronous API. And this can be extended. In fact, it already is extended here, and you can override anything that you don't see as helpful, or if you want to do something a little different, you can extend what's already built here. But it built a search API, and it built a get API and a patch API and a post and a put import and a page and general methods to help. And we can also extend the Open API spec. Open API, if I search for bicycle here, it's not found. We have automation to update the Open API spec and come back to it. And here we have our bicycle API ready to go. All we need to do is add a few fields that are similar to a person step, like, oops. Every bicycle would then have an ID, so we could just call this field bicycle ID. And then this behind the scenes will now have a new field called bicycle ID and some methods, getters and setters, and initialization code to persist that in this search engine. So I've been talking for a long time. This is how we develop our APIs, and they extend this bicycle step extends map result, as well as our person step model. So to answer Jim's question, how do we put these APIs together? This is how we do it here. Now, we're gonna talk about what's next for the Smart Village project. Let me pull up some slides here. We'll go back to our slides. And what's next? Here's our team that we worked together. We went to Boston University together and worked together on what's next. I want to pass it back to Yingqing to talk about what's next.
Thanks, Chris. And from a smart traffic light point of view, we want to extend it to multiple intersections. as someone just bring that out. And we also want the traffic network to automatically collaborate and create some so-called green wave in an long artery road. And we want to improve the driver's experience. And that's something we are working on now. Yeah. What's others on your side, Chris?
Yeah, so we met together at Boston University, and I want to explain who's in this picture here. We have Christos on the left. He's Yingqing's professor, who's leading this effort at Boston University, and the other many students who are part of Yingqing's team, who are interested in the project and doing their own research. And I was there with the Red Hat, along with Wanho from Phyware. Wanho is the CTO of Phyware, in fact, and we got together because we presented this project at the Phyware Summit in Gran Canaria, Canary Islands, and it was an exciting time, and it generated a lot of interest in open source technology and open standards around smart device technology. So Wanho set up a meeting with us to talk about our project and becoming an innovation hub around Phyware smart technology. So we are working on our open source software foundation best practices badge program to make our open source project especially credible in the world of open source. And we are following the Phyware generic enabler requirements to bring this innovation that we are building into the Phyware marketplace. And we are integrating with a Phyware context broker, which can run on OpenShift, thanks to the Open Innovation Labs team who worked on this project, and working with smart data models like traffic flow and crowd flow so that we can build that smart traffic light. Let me show you here. So in the bottom right corner, this was our team that went to the Phyware Summit. There's the Open Innovation Labs team, Jorge and David in the bottom, as well as Phyllis Westerman, who gave a keynote speech about what the Innovation Labs team did with Phyware together. And there's Jim as well, and myself, and then Jan and his son Tim, who started this project out in Veberöd, Sweden, and also Johnny, who's also our Phyware ambassador here at Red Hat. So they built the customized Kubernetes configuration components. They built the way to deploy the Phyware context broker on OpenShift for the first time, which is really exciting because it means that you can run OpenShift local, for example, and deploy the Phyware context broker and import any one of these smart data models from the 12 smart data model domains that Jim was mentioning earlier: smart cities, agri-food, water, energy, environment, sensoring, aeronautics, destination, robotics, health, manufacturing, and cross-sector. And it's not just engineers. We have exciting news that we're doing 2 hackathons with Red Hat Consulting at the Tech Exchange in February, where teams will work together and take on roles of data specialists, visualization specialists, documentation specialists, and OpenShift deployment specialists to use the context broker to find smart data and import that into their context broker running on OpenShift local. So there's this Red Hat success story about all of this that's linked here. And I encourage you to check that out on Red Hat's success stories. So these smart data models are really powerful, and we are going to be working with traffic flow observed and crowd flow observed models. We don't have to reinvent the wheel. Phyware already has the models defined to build these smart traffic lights, to to record who is in a particular lane on a road and in vehicles, and who is on the sidewalk as part of a crowd flow, for example. And so this is how the student research that Boston University is coming together with with the tools that we're building here at Red Hat to build an adaptive traffic light control, considering pedestrian flow. And that's what we're implementing here. So lots of fun things going on. And I want to pass it back to Jan for more about what's in the future.
Thank you so much. I'll try to share. What next? Well, we have a lot of thoughts, and some of them is like, what is sustainability? And often we look at economics or environmental, but not so often in social aspects. That is why I really love the social innovation parts. So this is a picture showing water consumption, but we are also trying to make a happy app. And we're working with that right now. And if that could be used, maybe we can do a happy app heat map to see if people are happy, more happy in some areas and maybe less happy in other areas. So if we can measure like happiness or noise or pollution or health or even loneliness, then we all of a sudden we can put AI over the organism of a village, a small society, and see connection. Are we more healthy using more water or other more fluffy questions? So we actually can see well-being, how's well-being they are in the village. Weber is going from 5,000 to 8,000 citizens, and that is really important in traffic flow, because that means maybe we get a lot more parking places. We have a lot more traffic flow, of course, and this is going to be done until 2040. And how would that impact on village feeling? We moved to a small village, a small society, because we like nature, quietness, and all of that stuff. What does that mean when we have more people into it? And mobility is just one of those questions. And we have some learnings and cooperations with nets or other like autonomous vehicles and or others micro-mobility. And we love to connect that to social welfare. Think about if you're sitting on a bus with 40 people, you are a lot more lonely than if you're all in like a bus like this, where you have mostly 6 people and you look at each other. Can we actually measure or increase the social welfare as well? So that is something we would love to heighten. We have a project called BASE, and it's how we try to connect a smart city like Lund with a smart village. What is the bottlenecks? What are the synergies? How can we have a flow in between the places? How can this work? And this we actually also work with Halmstad University. They have now professors and researchers coming down for a year of research of what is mobility together with social sustainability. What are the needs of the citizens? So we all maybe have heard of the concept of 15-minute cities. We tried with the university to look into 5-minute villages, which is Weber. And can we have a sustainable small village? And then we can actually scale this up to cities. And we have some cool findings in this. A change of society as we see it. As a village, digitization reduces distances. We have like 25 minutes for waiting for an ambulance in worst case. But we also have a lot of space and quietness, right? But digitizations get more like we have service, more security. So that takes away the need of growing villages to cities, actually. Maybe we should build a new village. And the other finding, which is also rather interesting, is that we can see cities consisting of villages. Maybe this work can be exported to cities, like village feeling in parts of the city. And we have also making a project, making this village more alive. So this is a research village in 3D that we want to employ. Also import buses, like have live buses, and we have done part of that, and we want to import those and see them live in the digital twin. So universities like Boston University can look at the digital twin, as can other universities globally, and use this with research programs and other collaborations with this. So this is a vision, a real goal for us to open up a small village for research. Thank you.
Thanks, Jan. Thank you, Yingqing. Thanks, Christopher. So the idea really is just to kind of plant a few seeds with you to give you an idea of, kind of the art of the possible, and, think about what we can do next. Could this be the subject of our next hackathon, for example, or another social innovation project, or something else completely different? So that's really the idea behind that last session. And yeah, now time for Q&A. We've kind of answered a few as we've gone along. If anybody's got any questions, please feel free to unmute yourself and ask a question, or ask a question in chat, and we'll get round as many as we can. Okay, so questions coming through. Right, okay. Question from Will on, how do we keep the IoT devices powered? I think that's probably one for you, Jan, working with Sensitive.
Sure. There are several IoT networks like LoRa or narrowband and stuff like that, but it's basically developed for space, where you have a lot of space, of course, distances, but a lot less power. So these small sensors are actually go into idle. They go into sleep. And when something happens, like change of temperature or accelerometer or anything like that, or just a timer, they wake up. And in that cases, we can actually have 10 years of battery power of very small sensor. We don't need power, basically. We just put the sensor out in the area.
Thanks, Jan. Did that help, Will? Great, thank you. Christopher, I don't probably direct this one to you. The importance of the Boston University Red Hat partnership and how cross-sector partnerships can fuel innovation. You've been like right in the middle of this with Yingqing, so you're probably the best one to answer this one.
Yeah, I am more supported to do this project through the Red Hat collaboratory with Boston University. It was a grant that was provided to our team to work on this project and bring me on board from Red Hat Consulting to do this development. So it's important to do that Red Hat research. The Red Hat research team, if you don't already know, works with universities and drives research and innovation into Red Hat products. It's really cool. So we are driving Red Hat research. Part of what we're doing, and something that relates to what Jaroslav was saying about, have you done any research on how to automatically analyze and sync all traffic lights in the village? Part of what we want to do next year is work with a new application apart from the Smart Village dashboard that can be deployed on the Red Hat Device Edge and Microshift that's very slim, that could be an embedded application in an actual smart device that has those sensors that observe traffic in this lane and pedestrians here, and makes those decisions to change the lights sequence. Yingqing is doing the research and development for that, and I'm helping to build that into an open source project and get it deployed on OpenShift, Operate First, and into Microshift on an actual device. So that's an example.
Thanks, Christopher. Yuri has a question. which I'll take if that's all right. With so many sensors and many metrics involved, have we also considered potential privacy issues? Now, there is a team within Boston University that deal with this. Because of the data we're handling at the moment, we haven't had a need to call on them. But just to let you know, there is a team that is able to, I always struggle with the best way to describe this, but they're able to aggregate data from different sources and present it in a meaningful way while still protecting the privacy of the individual data provider. And but at the moment, you know, we're just counting big blobs like motor cars or buses and things. And when it comes to deploying cameras, we will use things like pixelating the number plates, the license plates of the cars. We'll pixelate individuals' faces as well, so you can't identify somebody from the video. What we're interested in is the overall flow of either traffic, well, not of traffic and pedestrians at the same time. So you know, that's really what we're looking at the moment. But you know, rest assured, you know, we have a team ready and waiting to help us with privacy issues further down the line. Some of the things that Jan mentioned about the social sustainability, you know, we're going to be able to pinpoint an individual by their address to see whether they're happy or sad or whatever. But working with the team at Boston, we'll be able to aggregate that data and consume it in a way that it doesn't say, oh, Jan's not very happy. So we'll be able to make meaningful insights from the data without compromising anybody's privacy.
I would love to add something shortly there. We are looking into a bike theft app, and then you can buy and use that. But if we ask them to share the data, they have a discount, and that app is working right now. So we love to have live bicycle data put into this as well. But we just ask the citizens, can you share the information?
Thanks, Jan. Are there any more questions? We're almost at time. If anything, so Aaron, I mean, like all of these things, they're context sensitive. So if something pops into your head later on, drop me a note and we'll get back to you as soon as we can. Christopher.
Aaron Miller says, are there plans to present this at Summit? Should we submit a proposal?
Why not? Why not? I just wanted to say thank you very much to the panelists who, as you can see, have been doing a fantastic job over the last year. And if we, subject to funding, we get to continue this next year, then you know we're literally just scratched the tip of the iceberg there, if I'm not mixing my metaphors. And I also wanted to thank you, everyone who's kind of attended this event today. Hopefully it's planted some seeds with you and got you thinking about how you can use this technology on a Red Hat platform to deliver some positive outcomes for our customers. So enjoy the rest of the whatever part of the day you're in, and look forward to hearing from you over time. Thanks and take care. Bye for now.
Bye. Thanks.